purpose of this lesson is to show how properties are used to solve equations. You're familiar with solving equations last year in the 8th grade. So what we want to do today is to show you how properties are specifically what are used to make an equation or solve an equation to come to an answer. So let's take a quick look at the do now, which most of these should be pretty obvious. What happened between these two equations that allow them to stay true? We used the commutative property. In the second scenario, why are these two equations still true? Well, you should be able to see that we use the distributive property here, which resulted in the trinomial of x squared plus 2x minus 3. Now, if you look at the third example, what we did, and we'll get to what the specific property is in a moment, is we added 500 to both sides. Okay? And in the last one, we multiplied both sides by 3. Okay? Now, we'll get to in a moment what specific properties were used and what the exact terminology is to describe this. But what we want to do, and I'm going to skip through this question because there's an infinite number of answers. You could do just about anything to these to make it true. But the point is that if you think of an equation as a balanced scale, when you do something to one side of the equation, you have to do the exact same thing to the other side, otherwise it does not stay in balance. Now, you are asked to verify that 2 comma negative 3 is a solution set to this equation. This is not the coordinate 2 comma negative 3. It's 2 separate solutions. That's what the braces represent. So 2 separate times I have to substitute 2 in place of the x. And you'll see it's a very straightforward numerical statement. Does 4 plus 1 equals 7 minus 2? Yes. And be careful, negative 3 squared means it's x squared. That means that number times itself. That's why I put parentheses around it. Does 9 plus 1 equal 7 plus 3? Yes. So we verified that 2 negative 3 is a solution set. Now, Pete claims that the equation that we used above and his equation of x squared plus 5 equals 11 minus x has the same solution set. So he's saying this equation here, sorry to cross it out, and this equation here have the same solution set of 2 negative 3. Well, going through the same process, it's obvious that they do. Sorry, I know this is a little bit of tedious math. Again, it's still Friday afternoon, so not as sharp as I normally would be. So, Pete's statement is true. Now, why is Pete's statement true? What did Pete do to the original equation? Well, hopefully you're able to see that Pete added 4 to both sides. Since he did it to both sides, the equation stays balanced and the solution set does not change. Now we go to the next scenario where Pete's equation is adjusted by Michelle. And she still says that 2 negative 3 is a solution. Well, again, yes, 2 works. And -3 works. Now, what did Michelle do to Pete's equation? Michelle added x to both sides. Did adding x to both sides change the result? No, because x represents any real number. As long as I'm adding the same thing to both sides, I am fine. Now, we go back to that original equation, and Adam takes Michelle's and adjusts it. Again, I substitute in the 2. And I'm going to kind of cut to the chase here and tell you that 33 equals 33. You don't need to see that I know how to do my addition and subtraction or multiplication. Hopefully I do. Otherwise, why am I your teacher? And when you work all of this out, and I'm sorry, it should not be 11, it should be 33. You'll see that 33 equals 33. What did Adam do? He multiplied each side by 3. So, let's summarize what can be done here. Well, going the wrong way. And actually, if I recall, the video or my smartboard doesn't have the box that is on your note sheet, so I apologize for that. So what I'm going to do is improvise. Okay. And I'm just going to create that box, which is titled The Properties of Solving Equations. Okay. So I have 2 categories of properties. First are algebraic, and again, this is in your notes, even though it doesn't show up here, and properties of equality. And what are those categories? Commutative, which you'll recall these from the earlier lessons, associative, and distributive, which also includes combining like terms. On the other side, I have the addition or subtraction property of equality. And again, as long as I add or subtract the same number from both sides, and the multiplication slash division property of equality, with one caveat. You cannot, oh, I got a little crazy there. Equality. And I apologize for having to do some erasing here, but multiplication and division property of equality, and my caveat is you cannot divide by 0. because as you will recall, that leads to a answer that is undefined. Now, what I want to do with on the next slide, and since my orientation is off, it gets a little crazy here, so just bear with me for a moment. There we go. So I have the equation 3x plus 4 equals 8x minus 16. What are the possible first steps? Well, there actually are 4 possible first steps. I can subtract 3x from both sides. I can subtract 4 from both sides. I can subtract 8x from both sides, or I can subtract or add 16 to both sides. It doesn't matter, and here is the key point. It doesn't matter which property of equality is used in whatever order. I hope that's kind of proper English. Okay. So, when solving equations, there are many different first steps that you can undertake, and what can be done here are, at least there are 4 different first steps. All right, so let's finish up here. I have 8 equations, and I want to group them into 2 groups of 4 that are equivalent equations. And what are my groups of 4? Well, and I'm going to circle or color code them. A and B should be pretty clear that A times 2 is equal to B. Then, if you were to take B and divide each term by 10, you get D. And then, if you look at F, what happened in F is I subtracted a 6 from both sides from B. So those 4 are the same. Then if I were to look at, and it really doesn't matter which one you start with, but let's start with E. E and C, well, to go from E to C, I distributed the 3. Okay. In G, if you look at G, I multiplied E by 5. What you need to be careful about is, if you notice, I only multiplied the 3 by 5, not what's inside the parentheses, because when that gets distributed, that will take care of multiplying them by 5. And then H, I add 97 to it. So the point to today's lesson was to understand specifically what properties are used when you are solving an equation. And you need to be able to justify and identify what those properties are.